Okay, so here we have to find the integral 0 to 4 x plus e power 2x dx, and here we have to find this integral as a limit of sum, as a limit of sum. So this will be equal to um, so here we have to use the formula for the definite integral as a limit of sum. Definite integral as a limit of sum. So now here we have to use the formula, that is a to integral a to b f of x dx. That will be equal to b minus a limit n tends to infinity 1 by n into 1 by n into summation r goes from 0 to n minus 1 f of a plus rh, where h equal to b minus a by n. So when n tends to infinity, h will tend to 0. Or we can write it as a to b integral f of x dx, integral a to b f of x dx, that is equal to b minus a into limit n tends to infinity 1 by n into f of a plus f of a plus h plus dot dot plus f of a plus n minus 1 into h, where h is b minus a by n. So this formula we have to use here. So this can be written as integral 0 to 4. This will be, so here actually, sorry. So here a is equal to 0, b is equal to 4. So therefore h will be equal to b minus a by n, that will be equal to 4 by n. So this can be written as b minus a is 4. So 4 into limit n tends to infinity 1 by n into summation r goes from 0 to n minus 1 f of 0 a is 0 plus r into h, where h is equal to 4 by n. And here you have to take the function f of x as x plus e power 2x. So therefore f of 0 plus rh, that is equal to f of rh, that will be equal to obviously rh plus e power 2rh. And or we can say that f of 4r by n, since h is 4 by n, 4r by n, that is equal to 4r by n plus e power 2r into h, 4 by n. So that is 8r by n. Now therefore integral 0 to 4 x plus e power 2x into dx, that will be equal to 4 into limit n tends to infinity 1 by n into summation, this will be 4r by n plus e power 8r by n, and r will go from 0 to n minus 1. So this we can write 4 into limit n tends to infinity 1 by n into, first we have to put 0, so this will become r equal to 0, so this will be 0, and e power 0 is 1, so this will be 1 plus, then we will put r equal to 1, so this will be 4 by n plus e power 8 by n, plus we have to put r equal to 2, this will be 8 by n plus e power 16 by n, plus dot dot. At the end, we will get 4n minus 1 by n plus e to 8 into n minus 1 by n. So this will be this. We can write 4 into limit n tends to infinity. First, we can write this 1 plus e power 8 by n plus e power 16 by n, then plus dot dot plus e power 8 by n into n minus 1. Then plus it will be 4 by n plus 8 by n plus dot dot plus 4 by n into n minus 1. So this will be equal to 4 into, and here 1 by n should be there. 4 into limit n tends to infinity, 1 by n. Now this is a geometric progression. It is a GP, and this is an AP actually. This is an AP. And here, since here the difference is constant, the difference in between consecutive terms is a constant, and here the ratio in between consecutive terms is constant. So here, so we know that here we have got here we have got we have got n terms here, n terms. So it will be, the common ratio is e power 8 by n, so it will be e power 8 by n minus 1 and whole power n, actually whole power n, by e power 8 by n minus 1. Since we know that sum of n terms of a GP is a into r power n minus 1 by r minus 1. It is the sum of n terms of GP. And here this will be, we can take 4 by n as common, then we will get 1 plus 2 plus 3 plus dot dot till n minus 1. Now, this can be written as the integral I. Let's say the integral, this is I. So the I will be equal to 4 into limit n tends to infinity, 1 by n into, so this will be e power 8 minus 1 by, this will be by e power 8 by n minus 1. Then plus it will be 4 by n into the sum of n term, n minus 1 terms is n into n plus 1 by 2. So it will be n minus 1 into n by 2. So n and n will cancel here. 2 2s are 4. This will be equal to 4 into limit n tends to infinity. Then this we can, here we can divide by 8 by n and multiply by 8 by n. So then we can write limit tends to infinity 1 by n into n by 8. Then that into I can do, and this is a constant. So okay, uh, into this will be limit and here it will come e power 8 minus 1 by limit n tends to infinity, e power 8 by n minus 1 by 8 by n. Then plus it will be limit n tends to infinity. This will be 2 into n minus 1 by n. Since this 1 by n will be multiplied with this also and with this also. So this will be equal to 4 into so this will be 4 into this n and n will cancel. So this will be 1 by 8 and into e power 8 minus 1. Now we know that e power x minus 1 by x, limit x tends to 0, that is equal to 1. This we know. So therefore we can write it as this will be 1 plus this will be limit n tends to infinity 2 into 1 minus 1 by n. So here we can put infinity since 1 by infinity will be 0. So this will be equal to 4 into e power 8 minus 1 by 8 plus 2. So this will be equal to 8. 4 to the 8, 8 plus e power 8 minus 1 by 2. So this is the final answer. Thank you.